Matthew Perlman, and welcome to my shop. So today I'm going to be doing a review on a Chinese diesel heater. Now I know many of you have probably seen the hot air versions of the diesel heaters. This is a little different animal from one of those. This heats hot water, and it is a lot more powerful than the hot air versions that you typically see. Those are usually rated for 8 kilowatts. This is 17 kilowatts. If you do the conversions on that, it works out to roughly 50,000 BTU, or half of what a typical oil burner furnace does. So I did one test run with this last night, and I'm pretty happy with what I saw, pretty impressed with it. So I'm going to do another firing now. We'll give a little demonstration of this and just a review of it, a little bit about it. But what I got this for, I got this to keep my cat warm. For reference, the cat, let's show a picture of that, just so you guys don't get confused. Okay, so I have a 5-gallon pail of water here. That should be at least 5 gallons in there. This blue plumbing, I put that on just to get connected. So here is a pump that is comes with the unit. These are 1-inch fittings on here. They just accept hose fittings. Actually, that part comes with it. The pump is already attached. So this inlet here is a 1-inch ID for the hose, 1-inch ID for the hose. The pipe here is 3/4. I put one of these copper rings on the end of it just so I could clamp down with the hose. These, I believe, are either thermocouples or thermoresistors. It tells the computer in here what the inlet and outlet temperature are. So this is a water jacket from here out to here, and there's a combustion chamber in the center of that. There is a blower motor back here, and in this section there is some kind of like a scroll fan blower that brings air in through an opening at the bottom. I'll show that later. It mixes it with fuel. Your fuel comes up through here, and there's a glow plug under here. So the fuel, I guess, it gets sprayed onto the glow plug, ignites it, it burns through. And once this gets going, the glow plug actually shuts off, from my understanding. And this is like the computer to it back here. All the connections go through that. And there may be, I think this is just connection points here, but there may be some other circuitry under that. Okay, so this is my power supply. And actually I want to turn this down on the voltage, because these are meant to run with the vehicle stationary. They're not meant to be used when the vehicle is actually running. So I'm going to bring this down to 12 volts instead of a charging voltage like I normally have it set for. Now there's 2 power connections. These leads here on the long leads, these stay permanently connected on the vehicle, that they're always on. They're not keyed. And this is the control switch that you use to turn it on and off. And there's actually 2 positions on here besides off. You have off, there's a circulator that just runs the pump, and then you have to turn the burner on. So these, you have a negative ground and your positive. And at first I was thinking, well, why didn't they run that through the line and off this? But I believe the reason is so you can have the positive line for the control switched, that either you have it on accessory, so you could have to have the accessory switch on in order to run it, or you may want to have something that automatically locks it out, that when you start the vehicle it shuts it down, which you could do with a relay. Anyways, it gives you the option to do that the control part can be switched while the main power ones stay on. Now these have to stay powered on all the time, because it does go through a shutdown sequence. When you shut it, you can't just disconnect the power, or it can cause problems. So let me hook this up, and this is just a temporary test setup, so never mind that I'm just shoving these under here. So I've got a can with a few gallons of diesel in here, that's a pickup tube that came with it that you can take your diesel fuel tank on your vehicle, you cut a small hole in it, and there's a rubber gasket that goes underneath this, and you can mount it down. You've got a little filter that comes with it, and this is the fuel pump. Similar to the diesel hot air heaters, it's a ticker type pump, and the tick is actually controlled by the computer. It just gives a pulse to it, and it's like a solenoid that moves a piston in there, and every time it pulses, it measures out a specific amount of fuel. So this is what actually meters the fuel into it, besides delivering it. And let's fire it up, and we'll watch that temperature come up. When I ran this before, it took about 1 minute and 20 seconds to go through a start sequence as it heats up the glow plug and then feeds the fuel in. To heat that bucket from, I think it was 18C when I tried it before, up to its shutdown temperature of 80C, it took about 9.5 minutes, including the warm-up time. So, okay, so I'm going to turn the circulation on now. And it looks like it kept its prime overnight, so we're good to go. So you should be able to see circulation in there. And I'm going to start the start sequence. So we've got a light here, indicates that it is coming on. Okay, the blower started. The pump over here will start ticking in a few minutes. It's going to wait for the glow plug to heat up. While we're waiting, I might as well do a walk around here. So that is the inlet for the air inlet, and this is the exhaust. On this unit, I think it was 1.5 inches outside diameter on that. And we'll just walk around here. That's the back side. This is the connection for the fuel pump, and this feeds the pump motor. Okay, so it's starting to feed the fuel. It should be lighting up. And I forgot to set my timer. I'm going to do that right now. Okay, so we just ignited. I'm a few seconds late here, but this is from the ignition point that we're starting time. See if we can see anything for temperature. You can start to see a little bit of heat here in the thermal camera, and there's heat from the exhaust. You can see it on the floor there. In fact, you can see there's a little bit of plume from the exhaust. Yeah, I'm getting a little more smoke than I did the last time when I started it, but I expect that that's going to clear once it warms up a bit. This is already up to 24C. This midsection does get quite hot, so you do need to keep it away from anything flammable. I mean, it can be a little bit away, but you don't want it right up against it. And we're over 30°C already. Water in the bucket, or at least the outside of the bucket, is up to about 24 and rising quite quickly. $35 on the unit. On the bucket already. Runtime. I have 46°C on the unit. And 35 on the bucket. 36. 37 already. So the temperatures on this, it will run up to about 80°C, 82°C, and then shut down. And when the water temperature cools down to 60°C, it will restart. So it will maintain between 60 and 80 degrees Celsius. For Fahrenheit, that's about 140, and I believe it's 190 for the upper end, 180 or 190, somewhere in there. Basically operating temperature for the engine. At the bucket, and it's 5 minutes 40 seconds. 50C. Should have had that in view. So as you can see here, some of the body temperatures, they're quite high. That's almost out of range of my camera for this setting. I do have another setting that goes higher, and I think the highest I measured the other night was 250C. That's on the body, where the burner is. Okay, so we got 70 on the unit. And we're almost at 60 for the water in the bucket. And as I expected, most of the smoke is gone now. I can't see anything coming out for smoke at this point. I think overall it burns pretty clean. And in case you're wondering about monoxide in the shop here, I do have a carbon monoxide detector. When I ran it last night, it never set it off. Not that I recommend running it long term inside, but for a short test like this, I think we're okay. And the alarm will go off if it's not. Okay, so the body's pretty close to 80 right there, a little over 80. See what the water is. I'm showing 70C for the water. And that's on the outside of the bucket, so that may be a little bit colder than it really is. Looking at the water, I'm seeing higher. That's showing right about 80 right now. I didn't think the camera would pick up on the water, but it seems to do it. Okay, so I'm expecting this will shut down pretty shortly. I've got 79 on the outside of the bucket. at 82 on there, and that's right about where it shut the other day. So the fuel pump is no longer ticking. This is a cool down cycle. It's going through its shutdown sequence. The outside of the heater itself got up to about 90. So I'm going to shut the thermal camera now. So this run took a little longer. It was a little under 13 minutes, but it is colder in the shop today than it was. And I suspect that as you use it a little more that the carbon builds up in there and it's not quite as quick with the carbon in there. The first one, it was perfectly clean, so probably ran a little faster then. But still quite fast to heat 5 gallons. Okay, so now it is fully shut down. It's just the circulator pump running. So I think with this video, I think you can see all the steam coming off of this circulator pump, and we can shut that now. I won't do the restart sequence because I'd have to wait for like almost half an hour for this to cool down enough for it to restart. But I know it works. It restarted fine on its own the last time I ran this. And I think you have enough information to know what it is. Definitely a big difference with this from the little air ones that you typically see. I wanted to do a review on this because I looked for reviews before I bought this and I could not find any on this type of unit. So hopefully this is helpful to someone out there that has seen these and has some interest, or just informative to know what's out there if you haven't come across them before. They're mainly meant as block heaters. You can use them for other purposes. I don't know if I want to put drinking water through it directly because I believe this is like it's just a plain steel and it will rust if you don't have like antifreeze in it. But you could use a heat exchanger to do that. You could use it to heat a camper or even a small building, and actually it'd be more than just a shack. The little air ones will actually do like a small little tiny shack. But believe it or not, for the size of this, if you figure it by BTU, it's just half the size heat-wise of a full-size oil burner that typically heats an average home in the U.S. So quite a bit of power. Now the durability probably isn't going to keep up with, a home furnace is meant to run for years on end, cycling through the winter, and its components are designed to handle that with minimal maintenance. So I forgot to mention some of the specifications here. The fuel drawer on this is 1.76 liters per hour. That works out to a little under half a gallon US gallons per hour. To be specific, conversion here is 0.4649 gallons per hour. I took some current readings from my charger unit here the first time I ran this. The motor was drawing about 5.5 amps, and I noticed this time it went down a little bit. So I suspect that there's a break-in period on the pump where it wears the seals, and that will probably lower some. The motor on here actually rates about half the power that it's drawing. 3.2 amps is what it's rated for. So I think it's running a little bit over right now because it's still stiff. It doesn't have any runtime on it other than maybe 20 minutes total. So the pump right now was a brand new, running at 12 volts, a little under 5.5 amps. Startup of the unit when it's heating the glow plug was 14 amps. And running with it burning and the glow plug is done was 10 amps. And I expect all three of those figures to go down as the pump breaks in. So it may drop maybe another 2.5 amps below that. So hopefully that gives you a little bit of an indication of what its fuel consumption will be and power draw. Now mind you, with the short runtime, that fuel consumption works out to be very little. But I'm heating this all the way up to 180. So with that fuel consumption, consider what it would take to heat your engine up. Right now we're heating this to 180 degrees Fahrenheit. But to start a diesel, you would only need to bring it up to 17°C, 60 Fahrenheit. Your diesel will start easily at that as long as it's running properly. So for it to heat that up to that is only going to be a short amount of time, probably less than it took to heat this 5 gallons all the way up. So your fuel consumption would be very little. You know, if it takes 10-15 minutes to heat your engine up, you're only burning like 1/10 of a gallon to heat it up at most. So hopefully that's helpful to you, and yeah, I'll leave it at that. If you've made it this far, I hope you've enjoyed watching this video and found it entertaining or educational. If so, please consider hitting like or subscribe. It does help give me incentive to continue producing more. Thank you.